Hi friends, really excited to have you here with me today. I'm going to show another example out of Daniel Liang's Introduction to Java Programming. I'm continuing in section 9 on the big integer just because I'm fascinated by this whole concept of an infinitely large set of numbers, or seemingly so, bigger than I can get my head wrapped around, I can fit on my computer. So we're going to work through exercise 18, find prime numbers. So let's look in the book. What it says is large prime numbers. Write a program that finds 5 prime numbers larger than long dot max value. Cool. So let's go ahead and copy this. Let's pop over here to Eclipse. And what I would like to do inside chapter 10, section 9, I'm going to make a new package first. And I'm going to call this Chapter 10, exercise 18. Finish that up. Then in that, I can add a new class, and again, chapter 10, exercise 18. And this one, I'm going to include the public static void main. Go ahead and finish that. Make sure it'll start and stop. This is my little sanity check. Because if you get that far and nothing happens, you're going to have you need to shut her down and try again. And let's also make sure that we know our code is completing correctly, especially when you're working with prime numbers and hunting for things. So let's go ahead and paste in the problem description. So what's going to make this interesting is this whole larger than part of it, right? So let's go ahead and let's get started. So let's say, let's have int number primes to find. And let's start that out with, 5's not bad. And then int starting value. And let's make this 3. So the reason why I picked 3, I believe 3 is prime because it's not divisible by 2. And it is prime. And so we were going to find things larger than 3. So what we're going to do, 4 should not be prime, 5 should be prime, so that should be our first one is 5. 6 is not prime, 7 is prime, 8 is not prime, 9 is not prime, 10, 11, and then the list will go on, and we should get up 5, and we should be able to, with relative ease, to be able to identify, yeah, these are okay. So it says, write a program that finds 5 prime numbers, and that's, let's start this as a comment. Write a program to find 5 prime numbers. Okay. And then I'll just call it find primes. And let's go starting value, comma, primes to find. Cool. Now it's going to complain because it don't exist, right? So we'll go ahead and create it. And so now, gonna get rid of that. Static is fine, void is fine. Static, so it goes across the whole class. Void, it doesn't return anything. Private, only people in this class can call it. And we've got starting value. So we will say, let's do int offset equals 1. And then let's go Boolean, keep going, equals true, because I'm going to have a while loop. And I'm going to use that keep going statement inside my while loop because I want to just loop until I find all my prime numbers. So while keep going, and then we'll set this up. And then we'll come down here and we'll say, oh, one of the things we need to keep track of, int primes found equals 0. And then I'm going to just come in here and I'm going to say primes found plus plus, assuming that we would find one. If not, we're going to go ahead and put that into a if statement for when we have found a prime, and we'll just index this. And then we'll say if primes to find is now less than, actually, let's do if primes found is greater than or equal to primes to find. I like it better when these are all on separate lines. And then we'll say keep going equals false. So that's our stopping criteria. And then I'll add in here S out. We found a prime. So found a prime. It runs like 5-ish times. I'm going to change this down to 2, just so it's less to count. 2, we found a prime, we found a prime. Okay, cool. Okay, so now we've got a place to get started from. So now let's say, all right, so is our starting value prime? And then, so let's do it this way. For int index, let's say check value equals, 2 is really the first number that I'm worried about. And then check value less than, so there's some cheats. Let's see. See if there's any. Yeah. Hopefully these guys have a few ideas. And I got some C code. Skip 0 and 1. And 2. Oh, okay. So they're just going up to half of the numbers. A square root is usually another good limit. So you do like a round up on that, but you know, half, that should work. So I mean, if you think about some of the, we know 2 times 2 gets you 4. 2 is half of 4. 3 times 3 will get you 9. 4.5 is half of 9. So that should work to just go up to 2. Let's do. It just, calling it starting value irks me, so I'm going to call it working value equals value. So the concept is that's going to be my working value. Divide that by 2. Um, and I'm drawing a little blank right now. Is it round? No, okay, I've got to go look up what the syntax is. Java roundup. Math.seal. Okay, so what I need here. All right, and as a simple rule, anytime or anything I'm doing anything weird like that, and then you should usually use a print statement to verify that what you've done is actually what you intended to do. Okay, so now we'll put this inside a bracket, and then Control A, Control I. Probably need another right there. Yep, that'll do that. And then let's just print off what our check value currently is. So what's our starting? 3. So 2 and 2. If our working value is 3, so that's not gonna, that's let's just pop that off. Let's just do makes our code easier? Yes. Is it going to make our computer work harder longer? Yes. Yes, it will. Okay, so that's good. We don't really have that working yet. So that's our check value. And we say, let's come up here. Boolean is prime equals false. We come here and we're going to say is prime equals true. And then we'll say if if 0 is equal to the value of our working value modulo check value, so if 0, then we can say S out is not prime. So I probably want to take this little line right here, come up, paste that there. By the way, that looks clunky. There we go. Is not prime, and then we can do is prime equals false. And then we can say if is prime, then, whoops, that there. Then we can say, yeah, like that. Oh, and then our last condition, we need to say our working value let's go ahead and just make that one bigger before we go to the next loop. Okay, let's see if we've got that running. All right. Let's get rid of that. Okay. If is prime, oh, and we should also probably print off what that was. We found a prime. I just like to mix it up just a little every once in a while. So we'll do found a prime, %f, found a prime. Let's do, I think it's %d, \n, comma, working value. See if I screwed up the print statement. Yeah, hey, cool. Cool, that's pretty cool. Okay, so prime's defined. Let's go ahead and make that into 5. And so 3, 5, 7, 11, 13, 1, 2, 3, 4. I can believe that all of those are prime numbers. Cool. Just to kind of play with it, let's go ahead and make this a little bit bigger. 4 ones. Don't think that's prime. Nope. But it says 1,117. Okay. So I think we've got this started. And so this is, I feel good about our little custom method down here. I feel good about all the logic that we have working in it. The only problem is it doesn't work with big integers. You know what? I'm going to tidy this up just a little bit because I'm not using these print statements. They were mostly debugging print statements. We'll get rid of this as well, just to kind of tidy that code up just a little bit. Okay. All right. So what I'm going to do now is I'm going to say, I'm gonna say, let's just, our entire code up here in essence is 1, 2, 3 lines of code. And the part that's doing the work really is this part. And so what we need to do, or what I would like to do, is to go ahead and leave the program to find 5 positive numbers. We'll leave all of our old code the same and we'll leave it intact. And I'll just do, let's do int primes to find big int equals 5. And we'll say int starting value big int. And again, I'm going to leave that to be pretty much the same. Just to simplify my little brain, simplify life for my little brain, I'm going to change these numbers back. And so we can still run that. We've still got our results. 3 and 5 are the first 2 prime numbers. And now I'm going to copy this line of code. And now I'm going to call it find primes big int. And starting value, I'm going to paste that in here. Primes defined, I'm going to paste that in here. And now it's going to say, hey, I don't exist yet. So this line of code is actually not right. Let's just, I've got another example that I just worked not too long ago. And so the way you declare it is just like that. So we'll pop in here and I'll say big integer starting value equals new big integer 3 plus quotation marks. Is that the right syntax? Oh, probably wants me to import big integer from java.math. Okay. Is that how they were? I think this is the example. No, big integer example. Yeah, we could have just done, and this is probably easier to do. So I'll just do that. Okay. Now it's still complaining because I haven't created it yet. But now I've at least got the right number type. And so now I can create. Okay. So I'm not using my to-do list today, so I'll just get rid of that. And then, okay, so I have learned a little bit about working with my big integers that I've learned it's useful to do as much creating with the big integers inside the while loop as possible. So the Boolean though, we're not going to be creating that. Primes found, I'm not going to create that. Is prime, I'm not going to recreate that. So those will all go there. And while keep going. I tell you what, we'll continue to go nice and slow and just grab little bits at a time. Make sure that everything stays nice and pretty. Now, I'm not going to run it because as soon as I run it, this thing is going to go off the rails. So we're just going to kind of try to recreate it as much as possible. So we'll come in here and we'll do those two little lines saying a prime is found. Now, the problem it has is it doesn't know what working value is. And so I'm going to come in here and I'm going to say, working value equals new big integer. And I'm going to say this is going to have the value of I'm gonna cheat just a little bit. I'll do long offset equals 1 plus offset and then I'll come here and I'll do plus quotation marks. Ah, you know what? That's why that won't let me get away with that. Okay. So let's try this. Starting value big int dot add new big integer of there we go. And we need another parentheses to close that. Okay. So working value, big integer starting value. I'm going to actually start it off at 2 this time. Actually, no, 3 will work just fine. And then we just change our offset to 0 so that we can, oh, yep, you know, probably ought to add in the if statement. Here, so we can say, all right. There we go. Now we can run it. 3, 5, 3. Okay, we should probably clarify run for ints, and then come down here, and then run for big ints. 3, 3. Cool. All right. Hey, you know what? We're making steady progress. So we've got our starting value. That's good. We've got our termination, so that's good. All right. So we've got. Let's see what else we can do. So let's grab this little block of code here and see if we can get this up in here. So we'll separate this a little bit. So is prime equals true. All right, check value. Okay. Check value. The problem is working value is probably going to be a big integer. And so check value, what we're going to have to do here so that this is still, we can do a comparison. This is going to be something like, let's do working value dot all right, let's just pop over here. Big integer Java comparison. All right, compare to equals, all right, 0, the big integer is equal. Okay. So that's going to be a little bit of fun. Different way that we could do that. All right. Let me just ask a stupid question. Let's see if Java for loop with big integer. Says use this syntax. Hey, so you can actually get away with this. All right. All right, big integer. They're doing it counting down, but the idea is you basically make your values that you're working with big integers, and you can still have cool dot compare to. We might have to play around with this part a little bit. So 0 is equal to 1 if the value of the big integer is greater than that of the as a parameter. So and -1 if it's less than the parameter. Okay, got to admit, going to take my head a little bit to get wrapped around that. So let's go nice and slow. We've got our for loop here, and big integer. We just call it a big integer. Yeah, we can set that up. Instead of an int, you are now a big integer equals new big integer, and pop that there, pop that there. Okay, let's go ahead and word wrap this. And what do they do for the end of loop behavior? So in theory, I should be able to do something like check value equals check value dot add, and then they're calling big integer dot one. Big okay. Control A, Control I, save it. Okay. Now we've got to get this working, this center part right. And so, oh, by the way, I have enough doubts. I'm going to add a print statement for when we do get this running. Okay, now working value, how did they phrase that in the for loop? Dot compare to big integer. So what they're doing here is they're counting down to 0. So we are counting up to our, yeah, so we do bi dot compare to, and then we'll put our value here in the middle, and then we'll have to figure out what to do on the comparison side. So it's going to be working value dot compare to, and this is going to be our, oh, I see what they're saying. This should be check value, and this should be working value, and so this one, nope, this one, 0. So let's just make this like that. Okay. Yeah, there's a mod operator. I remember that. So what it's saying is we need dot mod of all right, well, let's see. So what is the complaint here? Oh, I see. No, check value should be a big integer. Working value should be a big integer. Ah, 0. So what we need is we need to change this. Let's pop this off. We need to say big integer dot 0 dot equals there we go. All right, now let's just try to run that right quick. So nothing blows up, but we've got a little bit of work to do yet still, right? So let's just read through what we have. It does find 3 as a prime, so that's good. Nothing's blowing up yet. Primes found. I guess now we can come in here and we can add. Actually, we've got our for loop. What else? Essentially line 41 is the start of our for loop. Let's come down and look at this for loop. We basically have one if statement that we had to modify, and then okay, so we can now just kind of grab this and wrap around our primes found part, and we just come here, then Control A, Control I to do the smart indent thing. Okay, and now, yes, we have to find a way to do increment our working value. So I'm just going to try to get really lazy. Actually, so line 62. Let's do offset plus plus. And let's try that. It says 4 is a prime. This is why I like small numbers, because I know 4 is not a prime. All right. So is prime equals true if okay. So let's read through this a little bit. So it comes in, starting value of the big int is 3, primes defined is 2. Keep going is true, primes defined, primes found equals 0, is prime equals false. Keep going is true, so we come in here, keep going is true. We make working value. This is our starting value plus our offset, which was 0, and so that gives us, well, I have no idea what that gives us, so let's just write starting value plus working value. So get that. All right, starting value 3, good, and then starting value does go to 4. So that's, I mean, hey, you know what? That's a small thing. Now, says 4 big integer check value equals 2 compared to working value. When that is equal to 0, then we should stop. So starting value equals 3. Okay. So 2 compared to 3. So we know our check value starts out as 2. Our working value is 3. According to the internet, big integer is less than, then it should be a negative 1. Let's try that. Cool. All right, so let's read. We found a prime 5. We found a prime 3. Run for ints. Run for big int. Starting value 3, check value 2. We found a prime 3. Starting value 4, check value 2. Starting value 5, check value 2. Cool. I think that might have just solved my problem. And so now let's get rid of some of these print statements. Save it, let's run it. Cool. So now we seem to be getting kind of the same-ish answers. Okay, so then we change this, I think, to 5. And let's also change this to 5. And let's save it and let's run it. So 3, 5, 7, 11, 13. Cool. And I think the other one we did was like 111. And so now I can run that. And we get the exact same numbers, which is good. And now we've got that going with the big integers as well. And we can look at how the two codes are different. But we can also use it as a tool. All right. So now we need to find out what is the value of long max value. Well, I think you can actually get away with, and I'm gonna cheat just a little bit. I'm gonna copy that because that line of code still makes me happy. But let's do long dot max value, and then you just, I think you can get away with that. And I'm gonna trim this down to 2 for just a little bit. Yeah, the reason I trimmed it down to 2 is because it makes it run for just a little bit and makes it think just a little bit harder. All right, so here's what I'm gonna do. I'm gonna go ahead and I'm gonna pause the video, and I'm also gonna get a stopwatch. I'm gonna start my watch, and I'm gonna see how long it takes to run these things. So it might take a little bit, it might take a lot, but I wanna have a stopwatch running so I can tell you how long it took on mine. So change this to 5, save that. I'm gonna start it running. Oh, I was just kidding. Go ahead, stop that. Okay, start it running. Stopwatch is running. I'm gonna pause the video. Okay, so it's ran for a minute and I'm starting to get bored. So I'm gonna slow that down just a little bit. And I think there's a way that you can get away with this. I think it's int dot value. Will you let me do that? Oh, int. No. All right. Let's do max value of int in Java. Yeah, primitive data types. Int and then literals. Let's do Java max value. Cool. See if it gives me any options here. Static int max value is a constant. So maybe, integer.max value. Okay, let's try that. But back here, let's try integer.max value. Make that. Okay, all right, so now, go ahead and stop this, by the way. Save it, and I'm going to run it just for integer, not longs, integer. And so starting now. All right, so I'm going to pause the recording, and then I will come back to you with more updates. All right, friends. So what I wanted, make sure, okay. What I wanted to show you, this has been running for about 2 minutes. And as you can see, probably the number one thing that's eating my lunch right now is this, let's see, I'll make that a little bit bigger. Something called Liang chapter 10, something or other. I don't know, it's like somebody's running a program or something. Yeah, this Eclipse program is absolutely eating the lunch of my computer, and you can see how the CPU commitment, it'll bump up and down. It's just kind of taking one thread, running it as fast as it can, and then it's switching back and forth between the hardware threads that it has. Hey, so 251, grab this. That was at about 3 minutes. I should make a note. Actually, just copy and paste the thing is easier. But this is something, this little bit of software right here is something I have installed inside my Ubuntu workspace called HTOP. I don't, Windows, the equivalent is your task manager. But the general idea is it just lets you say, hey, you know what? It's working its tail off right now. So it's going away, and it's grinding away. This is when there are some little things that you can do that should help this speed up substantially. Whenever we were doing this compared to working value, probably what we should have done with working value is just divided it by 2. So that's literally half as many numbers that we would have to check, and that would make this run twice as fast. There are other things you can do that'll speed this up. But I think I will go in, and I think I will try to play with the code just a little bit. And so here where I've got working value, I'm going to change this to working value divided by 2.2. And I'm going to call this and I think I'm going to, just to be on the safe side, I'm going to cast this to a double. And then I'm going to recast all of this to an int. So I'm going to go ahead and stop this, and I'm going to rerun it. So we should still get 107, 1017, 23, 29, 51, 53. Cool. So this one still works, and that one still is taking forever. So now let's go up here and compared to, this is actually going to be, how did we do rounding up? So A this is, okay, so this was C is equal to A dot divide by B, 2 decimal places, big decimal dot round up. So let's see if we can make my life more complicated, right? So this is going to be working value dot divide, and then this is going to be new actually I could just grab this line right here, new big integer 2, and then let's see, so we're dividing it, that's the value we're dividing it by. I want 0 decimal places, round up. No, okay, so I must have grabbed something wrong. Let's go see if we can, big decimal dot round, oh. So I don't know if big integer dot has a roundup. I'm willing to admit this may not work perfectly, but I'm going to guess it's going to have to work better than what we've done so far. I'm going to roll this back down just a little bit. Gonna pop back to where I'm using this code again. Save it, run it. Okay, so we are still getting the right results there. So it should be running about twice as fast. And we'll save that. So it took us about 3 minutes to find the first prime last time. I'll run it again. Got the stopwatch running. I'll go ahead and stop the recording or pause the recording for now, and I'll get you updates as we go. All right, friends, so we did find the next prime. The next prime took exactly a minute longer to find when we had the working value divide by 2. So what I'm going to go ahead and do, I'm going to pause the video again. I'm going to pop this out. I'm going to pause the video and get it running again, and then I'm just going to let it run for a long time, and I'll post my end results for timing for the integers in the code, and we'll go from there. All right. So I just wanted to show everybody, here's my resource monitor inside my my Windows environment. Here's the resource monitor inside my virtual machine. And what it says is, hey, my virtual machine is literally eating half of my stuff's lunch right now. Zoom is also eating a significant amount of my lunch as well. So my overall processor is completely smoked, but inside my virtual machine, it's also completely smoked. So the point of this discussion is this is what they were made for. This is what they were made to do. And so your processor should be okay. All right, friends. So this has been running for about 15 minutes and hasn't found another bigger number. So I'm going to go ahead and call that good for now. I've got it running on another machine with a faster processor right now, and I will let you know what I get for the results for doing it just with an integer, and then I will circle back and try with a long integer. So with that, I say thank you all for your time. Thank you for spending a little time with me. Improvements that I would suggest to see or like to see would be adding a timer function to this. And that way you've got the opportunity to see when it is these things get done, when they get done, and not have to babysit it. So with that, thank you all and have a wonderful day.